Okay. Today's lesson we're going to talk about one of the four conic sections. We're going to focus on circles. And you've probably done a little research at this point now, and you have a pretty good sense of the four different conic sections. What we're going to do in this set of notes is just kind of touch upon the stuff that we want you to focus on from your research. Now, one of the things that a lot of students run across that can be confusing with conic sections are the numerous equations that can be applied to all of the different conic sections, and it is a little confusing. I want to show you what we're going to deal with in this class and the depth that we're going to deal with in this class. And so you may have seen in some of your research something that looks like this. What this equation represents is the general conic equation, which means that this equation can apply to pretty much all four conics. Depending on what's been given to you, the A, the C, the D, the E, and the F, and what quantities those values are in the particular equation will dictate what type of conic section that you're dealing with. Now, in the case of a circle, the quickest and easiest way for us to identify this is that the A and the C are equal to 1, or the A and the C are equal to each other. In a lot of cases, you'll see it kind of look like this, if you will, and so then you'll know that it is in the form of a circle. So that is just a quick identifier, and of course A equals to C also tells us that this would also be a circle. Or potentially be a circle. So those are some quick identifiers. Now, that is very generic, and that is a little bit more in depth than we want at this point in the course. What our intent is to basically just introduce you to conic sections and the more standard forms of writing these equations. As you move up in math classes, you may then see a little bit more depth with the general conic section. So let's take a look at what we need to know in regards to circles. First of all, as always, you need to know the definition. And if you recall from geometry, you probably already knew the definition. The circle is a set of all points that are the same distance from a fixed point, which we call the center point. And that distance that is equal all the way around the circle is called the radius. So understanding the definition of a circle, knowing what the center of the circle and the radius represent are very important. Now, we're going to start with our circle basically talking about where it would be, what it would look like if we were talking about a center point of 0, 0. So we're talking about the origin on the coordinate plane, and going to some various xy point out there. So we're going to start with what we call the standard form of the equation of a circle. And you can see right here that we have the standard form is x squared plus y squared equals r squared. And of course, he told you up here that when these two are equal to 1, that's pretty much going to tell us that we're dealing with a circle. Now you notice that this is a little bit more condensed to show us the most basic, the most simplest form of the equation of a circle. And anytime you see the x squared plus the y squared by itself, you're dealing with a circle at the origin, or 0, 0. Keep in mind that the number value on the other side is always going to equal the radius squared. So if we ask you to find the radius, in the case of the example, we would say that the radius squared equals 9, so the radius would equal to plus or minus 3. Now, since we're dealing with distance, a physical property, we now know that negative 3 is not a viable option because we cannot have a negative distance. It must always be positive. So we can simply say that the radius is equal to 3 for that particular problem. Now, we also run into the case where we won't always have the origin as the center point, and this brings into play the h's and the k's that we've dealt with in the past. And if you recall, that the H tends to shift the graph side to side, and the K shifts the graph up or down depending on the sign. Now, keep in mind also, since we're dealing with an H and a K that are inside a set of parentheses, we are always going to use the opposite of the value. So if we have -3, that means we're just dealing with 3. If we have -2, we're just dealing with 2, and vice versa. So be sure that the opposite values don't confuse you too much in this particular case. So what we're going to do here is we're going to start our discussion of circles with some graphing problems. So we need to be able to graph the circle given the equation of a circle. This is the most common type of ACT problem when it comes to conics, so you'll definitely want to keep this in mind for the ACT. That's a very important concept. And so what I want you to do at this point right now in sample problem 1 is just to simply see if you can determine what the center point is using your H's and your K's and what the radius is, and try the best you can to graph this particular circle. Okay. Our first job is determine our H and K. Remember, the H and the K determines the center point. So in this case, remember, always using the opposite. So x minus 3 squared. So instead of -3, we're going to have a +3 for our H. But in this case, we have y plus 2. So remember, we're always taking the opposite of that. So in this case, we're going to have -2. And that's going to be our center point. So we're going to shift over on the H, 3 to the right, and then our K is going to shift it 2 down. And we're going to have the center point of 3, -2. Then we need to take into measure our radius. Now keep in mind this 16 is representing the r squared. So if r squared equals 16, then r must equal to a +4. Now, in graphing these, the simplest thing to do is to take your radius and count from the center point up and down and sideways. So what I'm going to basically do here is this. I'm going to start from the center point. I'm going to go up 1, 2, 3, 4. So that's a point on the circle. I'm going to go over 1, 2, 3, 4. That's a point on the circle. 1, 2, 3, 4. And then 1, 2, 3, 4. Now, it looks like it's going to give us a little diamond, and this is where sketching the circle is somewhat challenging. Notice I didn't go out to the side. I can't count diagonally. 1, 2, 3, 4. Notice that's going to be way out there. So you can't count diagonally, and we have no way of telling what 1 unit is at any of these given angles. So the easiest thing to do is just to go straight up and down and side to side to create our radius. Now, at this point, it's just like graphing a parabola from chapter 5. You just do the best you can to connect the dots with the smoothest circle possible. Now you may want to piece it together, and you may want to do it one little section at a time, or you may be better at doing it all at one time, depending on how much of an artist you are. Either way, just do the best you can. Now, since we're all not going to draw perfect circles, the most important part of this is to label all your points. So notice I've already labeled my center point. So now I'm going to label the following points. So I'm 3 over and 2 up this time. So that's 3, 2. This would be 3 over and down 6. And notice I could use my radius of 4. There's a distance between 2 and -2 of 4, and there's a distance between -2 and -6 of 4. And then for the far one, I'm going to go over 7 and down -2. And on this one, I'm going to come back 1 and down -2. And now I've graphed the circle perfectly and identified all of the given points that are necessary. So let's try that again. Part B, we have a little different scenario here. Notice that the equation is not written in standard form. So the very first thing that you would want to do is to write your equation in standard form before graphing it. So go ahead and give that a try now. Okay, so the first thing I need to do is I need to add x squared to both sides, which is going to give me x squared plus y squared equals 25. Now notice this time we have x squared and y squared without the parentheses, without an h and a k. So that's going to immediately tell me that my center point is going to be at the origin. Okay? And then the next thing we have to do is we have to deal with the radius. So r squared equals 25 and r equals to 5. Now, if you make a mistake on your radius, one of the first things that you can tell is if you accidentally use the radius of 25, that circle is going to be way off the graph. And so that would be a quick clue for you to know that maybe you messed something up with the radius. So just be careful of that. So r is 5. I'm just going to simply count 1, 2, 3, 4, 5, both top and bottom, and then 5 to each side. And then I'm going to simply do the best that I can to graph this circle by connecting all the points. And again, the most important thing here would be to label the points. So I have 5, 0. Here I have 0, 5. Here I have negative 5, 0. And here I have 0, negative 5. And so then that would be graphing of the circle. Okay, we'll stop right there and pick up with the rest of the notes on the next video.